Okay, so in this video we want to talk about how to use logarithms to solve equations. So we already know how to solve some exponential equations even without logarithms. You know that if a to the m equals a to the nth, then you can take m and set it equal to n. For example, if we have 5x times 5 squared equals 5 to the 7th. Well, let's rewrite 5 to the x times 5 squared as 5 to the x plus 2, it's just rules of exponents, and set it equal to 5 to the 7th. We can drop the 5's because they are common bases. Now we're just solving. X plus 2 equals 7. Well, x plus 2 equals 7. Subtract a 2 from both sides. You got 5. So all I did was drop my common base and solve the exponents. So we can do the same thing if it's a power of 10. Sometimes we have to put it into a common base though. This is 10x. So this we can rewrite as 10 squared. So now we have 10x equals 10 squared. I can drop my 10's. I have x equals 3. Stop your video and try the next two on your own. Okay, so hopefully when you solved all of these, you found x equals 3 for the first one, which we did together, x equals 1 for the second one because you just subtracted 2, and then for the third one you had a couple of steps. You had to subtract 1 and divide by 3, so you got x equals 1/3. So it's very simple, and we didn't actually have to use logarithms yet to solve this because we could just set them equal to each other. So let's do some more of the same stuff, but we're going to make it a little bit more challenging. So let's say we have 2 times 10 to the x equals 200. So before I can put this in a base 10, I want to get rid of the 2. Well, it's multiplied here, so I'm just going to divide both sides by 200. So now I have 10x equals 100. Rewrite your 100. So I find that x equals 2. So the only difference here was I had to get rid of this 2 that is multiplied first. Same thing here. Divide both sides by 3. 10 to the x plus 4 equals, now you've got 1,000, so 10 to the third, x plus 4 equals 3, so x would equal -1. Okay, so still, we were able to change it to a base 10 with no problem. What happens if you can't change it to a base 10? That's when your logarithms come into play. So remember, if a equals 10 to the b, and I wrote it right today, then log base 10 of a equals b. Got to remember your conversion. So here I've got 10 to the 2x equals 50. Well, that's just 10 to the b equals a. So I want to rewrite this as a logarithm. So I'm going to take my log, going to pull down my base 10, pull down my 50 because that's my a, set it equal to 2x. So now I can solve, take the log base 10 of 50, or the logarithm of 50, get 1.699 equal to 2x. All I have to do is divide both sides by 2. Got to get my calculator to do the next one. Okay, so same thing in the next example. I had 10 to the 3x plus 2 equals 43. Let's rewrite it as a logarithm. Bring down my base 10, it goes away. My 43 comes here. I set it equal to 3x plus 2. So let's find the log of 43, which is going to be 1.633 equals 3x plus 2. Now I can solve that by doing -2, which now gives me negative 0.3665 equals 3x. And then I can divide both sides by 3. I get x equals negative 0.122. Alright, so now we have this last one. Yes, we have to convert it to a logarithm, but we have all this extra junk in front of it first. Just like any other equation, you have to peel away some layers. So, we're going to undo the 7, so that now we have 3 times 10 to the x plus 4 equals 21. Still can't rewrite it because I have that 3, so now I'm going to divide both sides by 3. So now I have 10 to the x plus 4 equals 7. Now, I have something in this form that I can rewrite as a logarithm. So I'm going to log, bring down our base, 7 equals x plus 3. 3. So I'm going to take the log of 7, which is 0.845 equals x plus 3. So now I'm going to subtract 3. 0.845 minus 3 gives us negative 2.155. And that's how you solve equations using logarithms.